Hi, I'm Rich with insideHPC. We're here at ISC 2016 in Frankfurt, Germany, and I'm here at the SGI booth with Eng Lim Goh. How you doing today, sir?
Great to meet you again, Rich.
Yeah.
Last time we met was at SC15, was it?
Yes.
Yeah.
We were in Austin, and we were talking about, the coming changes with big data and HPC and the convergence, and I wanted to, check back in with you about that. What are you hearing here in Germany?
Yes, very similar, right? We talked about the last time how HPC could be a data expansion problem, and then HPDA, which is the data side, could be a data convergence problem, right? And how we can deal with things in the middle. And the update from that discussion is on the HPDA side. We are seeing more and more people asking about applying machine learning on top of the typical analytics that they do. So on this side, we've been looking at how we can categorize the different operations, right? You have on machine learning, supervised learning, right, as well as reinforcement learning. In fact, that's how the machine won over Go, right? The game of Go. And then there is also the unsupervised learning, which we believe is more on the analytics side, data analytics side. So the combination is becoming quite powerful on the HPDA side for us. And we are looking at that and the systems required, the architecture required to make that work well.
Okay, and at the same time, there's a lot of things going on in the hardware world, right? Like with these new memory hierarchies and things, and new GPUs and things like KNL, right?
Yes.
So put that in perspective. I mean, so now it seems like you have more tools, more toys to play with,
and busier, right? With the same R&D budget, right? You have to do more now. We improve efficiency to do so. Yes, you're absolutely right. On the HPC side, things are changing, right? You have the new memory hierarchy coming out. So programmers in the past who focused on making sure they write well and read well from main memory in one tier, now has to be concerned about up to 3 different tiers, right? So in the past, you have only DRAM DIMMs to worry about, but now you have HBM above it, and then soon you have non-volatile slower DIMMs below it, right? So from 1 tier, you end up with 3 tiers. So we have to work through the system architecture as well as the software stack so that our users can use that. So that's on the memory hierarchy side. On the accelerator side, as you rightly pointed out, you've got Knight's Landing that's been announced. You've got the GPUs from NVIDIA. I think the key there is increasing focus on machine learning and therefore half precision. So I think the way to categorize these different processes is, are you interested in half precision only, or interested in single, or interested in double precision? So that's another way of classifying these different processes.
Okay. And I saw a big change at SC, right? This my personal metric. Which type of business had the most new exhibits at the show? By far, it was deep learning with 12.
Yeah.
Now, this is from 0, and they expect twice that.
Yes.
So to me, this says a lot. I mean, what's really hot in supercomputing? I don't think I've seen anything with that kind of ramp up. So yeah.
I think there is a pent-up need, right, to start with. That is data, right? And we've been applying analytical tool, which is more on the unsupervised learning side of things. These are essentially statistical tools that have been around for years, right? But when you have data big and you want to do, say, for example, or even small data, and you do a traveling salesman type problem, they can get intractable. So the question is, what do you use? What algorithms do you use to try and get a good enough answer? Monte Carlo simulation, if you're familiar with that, approximation through simulation, another way, and then machine learning. Because in gaming, for example, right, in games with Go, chess, and before that checkers, machine learning was going through a process to be good enough to win over humans, but not necessarily good enough to give you an absolute best answer. So I think people are starting to realize that in addition to what we would call unsupervised learning, which is more analytics as we know it, more and more now they're moving up to supervised and reinforcement learning, and that's where machine learning starts to get a neural network and so on. Right? Yeah.
Okay. So I got to go out on a limb here. You know, you're one of the most visionary HPC guys. Come on, but. You know, somebody asked the poor guy Andrew are we going to get to HAL soon from 2001 and with artificial intelligence? It seems suddenly like it was always 50 years away. Now it seems more accessible.
Yeah,
what do you
much
think?
Closer.
Yeah.
The first point is it has been around, right?
Yeah.
We started with knowledge-based systems, and now towards systems that learn, right? And we have enough compute power to put it through a learning process that you'll get smart enough. And as I always say, you know, the vision 3 years out is clear. It gets hazy at 5, and I know I get I'm not so bold as to go beyond 5, right? Yeah. So I would see a system getting intelligent. You have enough resources to make them learn enough to be to augment human intelligence. I think that's the key. Key focus round. And then, of course, beyond that, right, which gets a bit more hazy, beyond 5 years out, you start to see giving machines that have done learning more autonomy with artificial intelligence. Then you start to have that question. Maybe you come ask me 3 years from now. I can give you a better picture.
Okay, fair enough. Okay, because that makes me think of the last question here. I mean, when the machine does learning, and the machine eventually wears out, does all that go away like with people, or can you take that and just move it over to a new machine to learn more?
That's the neat thing with software, right? Once you have learned, you can actually transfer and copy that learned environment to another machine that is faster. So that's the promise, right? Imagine. So all that you've learned, you see, that's the thing about more philosophical now, right? That's the thing about humans, right?
Yeah.
Hopefully we live 100 years or more, right?
Yeah.
And we spend 100 years learning. But after that software, the wetware, is if we can't like transfer it to some, but then AI machine could. See, so they continue to improve from their previous generation. Yeah, maybe there's a way to transfer our neural net, right? But that's way beyond, right? But the thing is, we can't really impart directly, right? What we have learned in 100 years or more.
Yeah. Well, now we do it with books and blogs and papers and such.
So there's an indirect way of transfer.
Yes.
Right. While the AI software, right? You actually make a copy of it. Yes.
Well, this is fun stuff to talk about, Eng Lim, but I really would look forward to continuing this discussion at Salt Lake City SC16 this year.
So we have these individual segments that keep add on to each other, right? We will do so.
That sounds great. Thank you.
Yes,
Good job.